Hello, dear students. Today we are starting Unit 3rd, that is sequence. First of all, we define the sequence. Sequence basically is a function, small s, whose domain is the set of natural numbers and whose range is any subset of R. If S is any subset of R, then we say that the sequence is of real numbers, or you can say real sequence. If n is small n is the element of this n, then you know the image of n will be Sn, and this Sn here is denoted by Sn like this, and the whole sequence is denoted by the symbol this or this. Here Sn is called the nth term of the sequence. For example, this is the sequence n cube. What about n belongs to capital N? It means we put n is equal to 1, 2, 3, 4 and so on. So the expanded form of the sequence 1, 8, 27 and n cube. The n cube is the nth term of the sequence. Now, what is the range of sequence? The range of sequence is the set of distinct element of the sequence. For example, if we take this sequence minus 1 to the power n, then put n is equal to 1, 2, 3, 4, then you will get the sequence minus 1, 1, 1, 1. Then the range of this sequence is the set of all distinct elements of this. So there are only two distinct elements, minus 1 and 1. So therefore the range set will be 1, minus 1. If you see the set 1 by n, so here range will be the set 1, 1 by 2, 1 by 3. So here the range is infinite. Now, constant sequence. Constant sequence means there is only one element in the whole sequence. For example, you can see 2, 2, 2, 2. So such type of sequence is known as constant sequence, and its range is always singleton set because there is only one distinct element in this sequence. Now we define subsequence. Let Sn be any sequence if n1, n2, nk, it is a strictly increasing sequence. Strictly increasing means n2 greater than n1, n3 greater than n2, n4 greater than n3, or you can say like this, for I greater than j, ni greater than nj. Then the sequence Sn1, Sn2, Snk is called subsequence of Sn. You can understand it with the help of an example. If Sn is the sequence 1, 0, 1, 0, 1, 0, then you can say this is S1, this is S2, this is S3, S4 and so on. So if we take N1 is 1, N2 is 2, N3 is 5. It means this first term, third term and fifth term. Then you can see NR is a sequence of positive terms such that N1 less than N2 less than N3 means N3 greater than N2, N2 greater than N1. Then the sequence 1, 1, 1. It is the subsequence of Sn. It means you have to care of order. For example, if we take this sequence, so you can see this sequence is the subsequence of this sequence 1 2 3 4. So here 2 is there, 3 is there, 5 is there, 7 is there. So you can see 3 comes after 2, 5 comes after 3, 7 comes after 5, 11 comes after 7. So it is a subsequence. But if we take 2 3 7 5, then it is not the subsequence, because 2 3 7 must come after 5. Similarly, 12 must come after 11 according to this sequence. So this sequence is not subsequence of this sequence. Now the next definition is bounded sequence. It is similar as bounded set. Same concept of bounded set. Here first of all we define lower bound and upper bound of a sequence. Definition 1. A sequence is said to be bounded above if the range set, we are taking here range set, not sequence. If the range set is bounded above, that is there exists a real number k1 such that Sn less than equal to k1. This is the same definition of upper bound. So here k will be the upper bound of the sequence. Similarly, Sn will be bounded below if there exists a real number k2 such that Sn greater than equal to k2 for every n belongs to n. So here you know k2 will be the lower bound of the sequence. And as you know, like a bounded set, a sequence is bounded if it is bounded above as well as bounded below. Means there exist two real numbers k1 and k2 such that Sn lies between k and k2 for every n belongs to n. This is the definition of boundedness of a sequence. A similar definition of boundedness of a sequence is said to be bounded if and only if there exists a positive real number k such that mod of Sn less than equal to k. If you want to show the given sequence is bounded, you can use this definition or this definition. There are two notes. The first note is every subsequence of a bounded sequence is bounded. It means if a sequence is bounded, then every subsequence of that sequence will be bounded. Second, if range set is of a sequence is finite, then the sequence is bounded. You know, every finite set is bounded. So if range set is bounded, then the sequence is also bounded. Now we are taking some examples of bounded and unbounded sequence. If you see 1 by n and use the definition of mode, then mode of Sn should be less than equal to k, that definition. So mode of 1 by n, you can see it is always less than equal to 1, because for n is equal to 1 it is 1, 1 by 2, 1 by 3, 1 by 4. The whole term of 1 by n is always less than equal to n. So it means with this definition less than equal to k, where k is positive. So 1 by n is bounded sequence. Similarly, you can see n upon n plus 1. If you put n is equal to 1, then it is 1 by 2, and you can see 1 is the upper bound of this sequence. So n upon n plus 1 lies between 1 by 2 and 1. It means 1 by 2 is the lower bound and 1 is the upper bound of the sequence. So it means this sequence is also bounded. If you take the example of minus 1 to the power n, it is always less than equal to 1, because there are only two elements, 1 and minus 1, and mode of both can be less than equal to 1. Therefore, with this definition, it is also a bounded sequence. What about the sequence? First, if you see the range set of this sequence, this will be 0, 2, because its every element is either 0 or 2. and this range set is finite set, therefore the sequence is bounded. And if we are taking this set n square and expansion of n square is 1 square 2 square, then you can see 1 square is the lower bound of this set, but upper bound does not exist. It means it is bounded below but not bounded above, therefore this sequence is not bounded. Similarly, you can take this example, minus 1 square minus 2 square minus 3 square. So here you can say minus 1 square is the upper bound of this sequence. It means it is bounded above, but there is no lower bound. It means the sequence is not bounded below. Therefore, it is not a bounded sequence. Thank you, students.